A beautiful spiral in the night sky holds cosmic secrets that defy explanation. The Whirlpool Galaxy is not just a pretty picture, it is a frontier of mysteries that challenge everything we think we know about how the universe works. By the end of this journey, you will know 25 of its strangest phenomena, each one a puzzle waiting for a solution. Why does its central black hole eat in such strange fits and starts? What is the source of the eerie harmonic music echoing from its hydrogen clouds? The answers could rewrite the textbooks of astronomy. What does it say about our universe that such profound mysteries exist right in our cosmic backyard? The heart of the Whirlpool Galaxy is a place of profound contradiction. A supermassive black hole, an object with gravity so intense that not even light can escape, should be a voracious and violent consumer of matter. Yet this cosmic giant eats in strange, quiet fits and starts that baffle astronomers. Its behavior defies the standard model of a black hole, which predicts a consistent, brilliant output of energy as material spirals into it through a hot, glowing disk. Instead of a steady cosmic beacon, we observe a surprisingly faint object. For its immense size and gravitational power, its X-ray emissions are whisper quiet. It is a sleeping giant that occasionally stirs without any apparent reason, erupting in sudden, mysterious flares. These bursts of energy appear and vanish, a flickering candle in the dark with no clear hand to light it. What could possibly cause such erratic behavior in an object governed by such simple, brutal rules of physics? The answer may lie in the very nature of the material it consumes. Perhaps the gas and dust falling toward it are clumpy and uneven, like a poorly made meal delivered in unpredictable chunks instead of a smooth, steady stream. Or maybe the magnetic fields around the black hole are tangled in ways we do not yet understand, periodically choking off the flow of energy. This is not just a puzzle about one black hole. It challenges our fundamental understanding of how these cosmic engines work, suggesting that the chaotic dance of matter at the edge of oblivion is far more complex and mysterious than we ever dreamed. This erratic feeding hints at forces operating in the shadows, and the greatest shadow of all is cast by something we cannot even see. Surrounding the Whirlpool Galaxy is a vast, invisible structure, a halo of dark matter that holds the entire spinning disk together. We know it is there only by its ghostly gravitational grip. The stars at the galaxy's outer edges whirl around the center at speeds that should be impossible. According to the laws of physics and the amount of visible matter we can observe, these stars should be flung off into the void like mud from a spinning tire. The fact that they are not tells us something profound. An immense unseen mass must be holding them in place, its gravity creating an invisible scaffold that defines the galaxy's very shape. But this is where the mystery deepens. The Whirlpool's dark matter halo is not just strong, it is strangely configured. Its gravitational effects are far more powerful than our models predict, suggesting the dark matter is clumpier and spread over a more extensive area than in other similar galaxies. Why would its dark matter be so unevenly distributed? One compelling theory points to the Whirlpool's famous dance with its smaller companion galaxy. This cosmic interaction, a slow-motion collision lasting hundreds of millions of years, may have stirred up the dark matter like a spoon swirling cream in coffee, creating dense pockets and vast, empty voids. Another, more startling possibility is that this unique structure is a fossil, a relic from the galaxy's violent birth, indicating a formation history entirely different from our own Milky Way. We are left staring at the gravitational echoes of an invisible world, a hidden architecture that may hold the ultimate key to how this beautiful spiral came to be. These gravitational echoes may have sculpted more than just dark matter. Deep within the swirling arms of the Whirlpool, another mystery is brewing, one that radiates a strange and silent heat. Astronomers call them unidentified infrared objects, or UIROS. They appear in our telescopes as brilliant, isolated points of infrared light glowing with the intensity of a furnace. Yet when we point other instruments toward them, searching for the visible starlight or the radio waves we would expect from a known type of star, we find nothing but silence. It is as if these objects are cosmic ghosts, visible only by the heat they leave behind. Their very existence defies our neatly organized catalogues of celestial bodies. They are too bright and too hot to be simple, cold dust clouds, but they lack the other telltale signatures of any known stellar remnant or newborn star cluster. So what are they? One possibility is that we are seeing a previously unknown class of celestial object, something that operates on principles we have not yet imagined. They could be exotic stellar corpses, the remains of stars that died in unusual ways, leaving behind embers that burn fiercely in this one specific spectrum of light. Another, more tantalizing theory suggests these UIROS are not natural at all, but the signatures of something else entirely. Could they be the waste heat from unimaginably vast alien megastructures capturing the energy of their suns? While that idea stretches the limits of credibility, it highlights just how perplexing these objects truly are. They are a fundamental challenge, a reminder that our maps of the cosmos are still filled with blank spots labeled "Here be dragons." These phantom arms ripple through the galactic disk like faint echoes from a forgotten event. When you look at a standard image of the Whirlpool, you see its two grand, majestic spiral arms bright with the light of newborn stars. But in the deepest, most sensitive observations, something else emerges. There are additional spiral structures, incredibly faint and ghostly, that do not connect to the main pattern at all. They are like pale scars on the face of the galaxy, tracing a different geometry entirely. These are not simply dim extensions of the arms we know. They are separate entities, a set of phantom limbs moving to a different gravitational tune. So what could possibly create such a ghostly imprint on a galaxy? The most compelling explanation points to a violent past. These faint arms could be the cosmic aftermath of a galactic merger, the lingering debris from a smaller galaxy that was torn apart and consumed by the Whirlpool eons ago. As that victim galaxy was shredded, its stars would have been scattered into long, looping streams, which over millions of years could have settled into these faint, disorganized spiral patterns we see today. It is a fossil record of a cosmic feast written in starlight, but there is another, equally fascinating possibility. These ghost arms might not be remnants of a past death, but the ongoing effect of a gravitational dance. The Whirlpool's smaller companion galaxy, which we know is interacting with it, could be acting like a stone dropped into a pond. Its repeated close passes send powerful gravitational waves through the Whirlpool's disk. These waves can compress gas and dust and even tug at older, dimmer stars, pulling them into new, faint patterns that ripple outward. These phantom structures are a direct map of invisible forces, a visible signature of the dark matter halo's gravitational field as it is stirred by its celestial partner. They challenge our notion of a galaxy as a stable, isolated island. Instead, they reveal the Whirlpool as a dynamic, ever-changing entity, its beautiful form constantly being rewritten by ancient collisions and persistent gravitational tides. What other ghostly signatures are hiding just beyond our current ability to see, stretching between the Whirlpool and its companion like a cosmic umbilical cord is a river of raw creation. This is the Great Gas Streamer, a filament of hydrogen gas so vast it bridges the intergalactic void. We are not talking about a wispy cloud, but a massive, structured current of primordial material, the very stuff from which stars are born. Yet this river flows in defiance of simple expectations. Its movement is chaotic, with pockets of gas surging at velocities that make no sense if this were just a passive flow pulled by gravity. Some regions are racing along far faster than the gentle tug of the two galaxies should allow. It is as if an invisible hand is actively pushing material through this celestial pipeline, accelerating it toward an unknown destination. The source of this extra energy remains one of the streamer's deepest puzzles. Could it be the result of complex tidal forces, the gravitational equivalent of ocean tides but on a million light-year scale, whipping the gas to ever higher speeds as the two galaxies swing around each other? Or is there a hidden engine at work, something within the streamer itself that we cannot yet see? The mystery only deepens when you look at what is happening along its length. In the deep, cold solitude of intergalactic space, where matter is supposed to be too sparse and quiet for such events, the streamer is dotted with brilliant newborn stars. These are not just any stars, but massive, hot, blue giants igniting far from the fertile spiral arms of either galaxy. It is like finding vibrant, isolated orchards blooming in the middle of an empty desert. Their existence forces us to reconsider the very conditions needed to spark star formation. The gravitational compression from the galactic dance alone might not be enough to trigger this. Perhaps shockwaves are rippling through the filament, or powerful magnetic fields are channeling and compressing the gas, creating dense, star-forming pockets in the most unlikely of places. This great streamer is more than a bridge. It is a testament to the dynamic violence of galactic interaction, a place where the empty void between giants is suddenly, improbably, alight with new suns. Amidst the chaotic beauty of the spiral arms, a structure of impossible geometry emerges. It is known as the Red Rectangle, and its name is not just a poetic label. This nebula presents a shape of such stark, angular perfection it looks as though it was drawn with a cosmic ruler. Two brilliant cones of glowing gas, back to back, form a perfect X shape, and they are enclosed within a sharply defined rectangular boundary of crimson light. This is not the gentle, rounded glow of a typical planetary nebula, the kind formed when a single, dying star gently puffs its outer layers into space. The Red Rectangle is an architectural marvel in a realm where fluid dynamics and explosive forces usually reign. So what force in the universe could possibly craft such a perfect, hard-edged form? The leading theory points to a celestial dance at its very heart. Instead of one dying star, the Red Rectangle is likely powered by a close binary system, two stars locked in a tight, mutual orbit. As one of them nears the end of its life and begins to expel its outer envelope, the powerful gravitational field and the whirling motion of its companion star act like a cosmic mold. This stellar partner funnels the ejected gas into two opposing jets, and as the entire system rotates, these jets precess or wobble, much like a spinning top slowing down. This wobbling motion over vast stretches of time paints the conical shapes we see. The material isn't just blowing out randomly, it is being sculpted with precision by an invisible gravitational hand. But the geometry is only half the mystery. The other is its shocking, deep red color. This intense crimson glow comes from a type of carbon-based molecule known as polycyclic aromatic hydrocarbons. These are complex, organic compounds forming on the surfaces of dust grains within the nebula, and they fluoresce with a rich red light when bathed in the ultraviolet radiation from the central stars. The sheer abundance of these molecules here is extraordinary. It suggests that this dying star system is not just throwing off simple gases, it is a factory for complex carbon compounds, the very building blocks of life. The Red Rectangle is more than a pretty shape, it is a cosmic chemistry set, forging the ingredients of future worlds and perhaps future life in its geometrically perfect crucible. What other secrets are locked within its sharp, crimson angles, scattered like brilliant, impossible diamonds across the Whirlpool's spiral arms are sources of power that defy all known physics. Astronomers call them ultra-luminous X-ray sources, or ULXS. These are not the faint, diffuse glows of distant gas clouds, but intensely bright, pinpoint objects. Each one emits more X-ray radiation than a million suns emit across all wavelengths combined. The problem is that should not be possible. our understanding of physics places a strict limit on how brightly a single cosmic object can shine, a rule known as the Eddington limit. It is a balancing act between the outward push of radiation and the inward pull of gravity. If an object tries to shine too brightly, its own light would literally blow away the very material it is feeding on, shutting down the process. A typical stellar black hole or a neutron star simply cannot generate this much power without tearing itself apart. So what are these cosmic rule breakers? One leading theory is that we are looking at a new class of black hole, one that has long been a missing link in cosmic evolution. These would be intermediate mass black holes with masses thousands of times that of our Sun, bridging the gap between the stellar black holes left by dead stars and the supermassive giants that anchor galaxies. Such an object would have the gravitational muscle to power these incredible X-ray beacons. But there is another, even more exotic possibility. Perhaps these are not unusually large black holes, but ordinary ones that have discovered a new, hyper-efficient way to eat. Instead of a smooth, orderly flow of matter, imagine gas and dust falling inward in a thick, dense torrent, like a waterfall crashing onto rocks. In this chaotic, super-loaded state, the radiation could be trapped within the inflowing material, unable to escape to blow it away. This would allow the black hole to gorge itself far beyond its theoretical limit, shining with a brilliance we once thought was impossible. Each ULX is a challenge, a tiny point of light that forces us to question the very laws that govern the most extreme environments in the universe. Are we seeing the birth of a new class of monster, or have we simply underestimated the sheer, gluttonous power of the ones we already know? The same cosmic violence that lights up the whirlpool with phantom arms and brilliant X-ray sources may have also robbed it of its ancient treasures. Orbiting most large spiral galaxies, including our own Milky Way, are dense swarms of stars known as globular clusters. These are cosmic fossils, each one a spherical collection of hundreds of thousands of stars, all born together in the galaxy's violent infancy. They are the oldest stellar communities in the universe, and a galaxy typically has hundreds of them, a glittering entourage of ancient suns. But the Whirlpool Galaxy presents a profound puzzle. For a galaxy of its size and majesty, it possesses a surprisingly low number of these ancient clusters. It is as if a grand museum has had most of its oldest and most precious artifacts stolen, leaving curious gaps in its historical collection. So where did they all go? The most dramatic explanation is that the whirlpool's turbulent past involved a catastrophic collision. As it danced and merged with other galaxies over billions of years, the immense gravitational tides generated in these encounters could have physically ripped these clusters apart. Their stars, once bound tightly together by gravity, would have been scattered into the general halo of the galaxy, becoming indistinguishable from the background starlight. It is a galactic demolition, erasing entire cities of stars in a single, violent event. But there is another, more subtle possibility. Perhaps the whirlpool never had a large population to begin with. The formation of globular clusters seems to be tied to the specific conditions of a galaxy's birth. If the whirlpool formed from a quieter, less dense cloud of primordial gas than other spirals, it may have simply failed to produce as many of these stellar behemoths in its youth. This missing population is more than just a head count. Each cluster is a time capsule holding chemical clues to the conditions of the early universe. Their absence means a significant part of the whirlpool's own life story is missing, a lost chapter that makes its entire evolutionary history harder to decipher. Did it lose its ancient jewels, or was it born without them? The answer would tell us if this beautiful spiral is a product of a violent upbringing or a uniquely gentle birth. From the heart of a stellar corpse, a jet of pure energy erupts in a shape that defies the chaos of space. This is the corkscrew jet, a stream of superheated plasma that spirals outward like a cosmic drill bit. It originates from a microquasar, the remnant of a star that collapsed into a black hole or neutron star, which is now actively feeding on a companion star. Most astrophysical jets are straight, narrow beams lancing across space like searchlights, but this one corkscrews through the void in a perfect, tight helix. It is as if some invisible hand is twisting the nozzle of a celestial hose. The forces required to create such a precise spiral are almost unimaginable. One leading theory points to immense coiled magnetic fields. As material is sucked toward the dense central object, it forms a swirling accretion disk. The magnetic fields embedded within this disk could become wound up like a spring, channeling the ejected plasma along these twisted field lines and forcing it into its helical path. But there is another, equally compelling possibility. The central object might not be alone. A hidden, unseen companion, perhaps another dense stellar remnant, could be orbiting it in a tight, fast dance. This gravitational tug-of-war would cause the entire system to precess or wobble, much like a slowing top. As the system wobbles, the direction of its jet would slowly sweep around in a circle, tracing out that corkscrew shape across the light years. This single, bizarre jet challenges our understanding of how energy escapes the most violent gravitational prisons. It reveals that the chaos around a feeding stellar corpse can give birth to structures of unexpected and beautiful order. What other cosmic geometries are waiting to be discovered in the outflows of these miniature monsters? Deep within the Whirlpool's vast spiral arms, clouds of cosmic dust glitter with the cold fire of a billion tiny diamonds. This is not a metaphor. Astronomers have identified regions where the interstellar medium is filled with crystalline silicate grains, particles with an ordered, gem-like atomic structure that causes them to sparkle with an unusual reflectivity in infrared light. This discovery is deeply puzzling because space dust is not supposed to look like this. Most interstellar dust is amorphous, meaning its structure is chaotic and glass-like, the result of slow, quiet accumulation over eons. Finding these crystalline grains is like walking into a junkyard and finding a pile of perfectly cut and polished jewels scattered among the rubble. Their very existence points to a dramatic and recent origin story. These crystalline structures are fragile. The chaotic radiation and shock waves that constantly ripple through the galaxy should disrupt their delicate lattices, turning them back into common, amorphous grit over a relatively short cosmic timescale. For them to still be here, shining brightly, they must have been formed recently and in a place of immense transformative energy. So what kind of event forges diamond dust on an interstellar scale? The prime suspect is a stellar furnace of unimaginable violence. When certain types of stars die, they do not go quietly. In their final stages, they can enter a phase of intense, pulsating outbursts, heating their outer layers to incredible temperatures before blasting them into space. This sudden, searing heat is precisely the kind of environment needed to bake common stellar soot into orderly, crystalline structures. It is a cosmic kiln, firing the raw materials of stardust into glittering particulates. Alternatively, the shock wave from a nearby supernova explosion could have surged through a cloud of amorphous dust, superheating it in an instant and triggering this same crystallization process. These diamond dust clouds are therefore more than just a pretty anomaly. They are a timestamp, a forensic clue pointing to a recent and violent event in the galaxy's history. They tell us that the Whirlpool is not a static museum piece, but a dynamic workshop where stars live and die, and in their death throes, they seed the void with the glittering raw materials for future planets and perhaps for future life. Far from the brilliant lights of newborn stars, a different kind of music fills the void. The Whirlpool Galaxy is home to immense clouds of neutral hydrogen gas, the silent, primordial fuel of the universe. But these clouds are not silent at all. When we listen with radio telescopes, we hear them singing. They emit coordinated waves of radio emission that form distinct harmonic patterns, a slow, deep resonance that seems to pulse through the galaxy's skeleton. This is not the random hiss of chaotic gas. It is a structured chorus, as if the entire cloud is vibrating in unison to a single, unseen beat. How can something so vast and diffuse produce such a coherent signal? The hydrogen itself is not intelligent, of course. It is simply responding to a force. One compelling theory points to the galaxy's magnetic field. Imagine a vast, invisible harp with strings light years long. As these magnetic field lines are plucked by the slow, grand rotation of the galaxy itself, they could vibrate, sending oscillations through the hydrogen gas that is trapped within them. This would cause the gas to emit radio waves in a synchronized, rhythmic pattern, creating the harmonic music we detect. But there is another, far more mysterious possibility. What if the force conducting this cosmic orchestra is not magnetism, but something even more elusive? The pervasive halo of dark matter that holds the galaxy together could be interacting with the hydrogen in ways we have never considered. Could the gravitational influence of this invisible substance, shifting and flowing on scales beyond our comprehension, be setting up resonant frequencies in the visible matter? This harmonic song is more than a curiosity. It is a direct probe into the forces that shape the galaxy on the largest scales. By deciphering its melody, we might not only understand the hidden magnetic architecture of the whirlpool, but also hear the faint gravitational whisper of dark matter itself for the very first time. These stellar anomalies burn with a fierce, youthful blue light where only ancient, dying suns should remain. They are called blue stragglers, and they congregate in strange, isolated swarms throughout the Whirlpool Galaxy. In the dense cores of old star clusters, where every other star has aged into a red giant or a cooling white dwarf, these brilliant blue stars stand out like teenagers at a retirement home. Their very existence is a direct challenge to our understanding of stellar life cycles. A star's color and brightness are a direct reflection of its mass and age. Massive, hot, blue stars are the rock stars of the cosmos. They live fast and die young, exploding in supernova after only a few million years. They simply should not exist in ancient stellar neighborhoods that are billions of years old. So how did these cosmic imposters get there? The most dramatic explanation involves stellar violence. In the crowded dance floors of globular clusters, stars can swing too close to one another. A direct head-on collision between two older, smaller stars could fuse them into a single, more massive star. This newly merged object would be reinvigorated, its core suddenly flooded with fresh hydrogen fuel. It would light up with the blue-hot intensity of a much younger star, effectively resetting its evolutionary clock. It is a stellar resurrection born from a catastrophic crash. But there is a second, more subtle process at work. Many stars exist in binary systems, two stars orbiting a common center of gravity. If one star in the pair begins to swell into a red giant, its outer layers can be gravitationally stolen by its smaller, hungry companion. This transfer of mass can fatten up the smaller star, making it more massive, hotter, and bluer, while the donor star is stripped down to its core. It is a cosmic vampirism that creates a youthful-looking star from the plundered material of its aging partner. These blue straggler swarms are not just celestial oddities, they are active crime scenes, evidence of either dramatic collisions or slow-motion thefts that rewrite the fates of stars. They force us to see star clusters not as peaceful collections of suns, but as dynamic arenas where stellar lives are constantly being altered, merged, and reborn. These stellar vampires and colliding suns are not the only violent actors in the whirlpool. Deep within its spiral arms, our telescopes have mapped strange, searingly bright hotspots of gamma-ray radiation. These are not the diffuse glow of the galactic background, but intense, localized beacons of the most energetic form of light in the universe. Each one is a cosmic mystery, a flash of profound power with no obvious engine. When astronomers search these regions for a known source, they find nothing. There are no recent supernova remnants, the expanding shells of exploded stars that are classic particle accelerators. There are no spinning pulsars, the lighthouses of the cosmos that often beam out high-energy radiation. The space around these gamma-ray flares is eerily quiet, making their intense output even more baffling. So what invisible hand is powering these celestial blowtorches? One compelling theory points to a hidden population of cosmic engines. We could be seeing the collective output of many faint, fast-spinning pulsars that are simply too dim for our current instruments to pick out individually. Together, their combined gamma-ray glow would create a single, brilliant hotspot. Another, more exotic idea involves the very fabric of the dark matter halo that cradles the galaxy. According to some theories, dark matter particles are their own antimatter opposites. When two of these particles collide, they would annihilate each other in a flash of pure energy, potentially releasing a torrent of gamma rays. The dense, crowded core of the Whirlpool Galaxy would be the perfect arena for such a catastrophic dance, creating these unexplained hotspots at the very points where dark matter is most densely concentrated. We are left staring at the possible signature of a ghostly substance annihilating itself in the dark, a process that could finally unveil the true nature of most of the matter in the universe. Even the light from distant galaxies is not safe from the whirlpool's hidden influence. As astronomers study the faint, ancient glow of galaxies billions of light years behind the whirlpool, they notice something peculiar. The light from these incredibly distant objects is subtly but surely being bent. It is a phenomenon known as gravitational lensing, where a massive foreground object acts like a cosmic magnifying glass, warping the fabric of space-time itself and distorting the images of background galaxies. Normally, the primary lens is the whirlpool's total mass, its stars, gas, and dark matter halo combined. Yet, when scientists map these distortions with extreme precision, they find small, sharp anomalies. In specific, isolated patches within the galaxy's disk, the bending of light is far more extreme than the surrounding region can account for. It is as if an invisible knot of immense mass is tied within the galactic fabric, a phantom weight warping our view of the deep universe. So what is this unseen anchor? One startling possibility is a rogue black hole, a solitary monster drifting silently through the spiral arm. This would not be a typical stellar black hole, but an intermediate mass object weighing perhaps thousands of solar masses, left behind by a disrupted star cluster or a failed galactic core. Untethered to any bright accretion disk, it would be completely dark, its presence given away only by the way it twists the light of galaxies far beyond our own. An even more profound explanation points to the dark matter halo itself. We assume dark matter is spread in a smooth, if clumpy, distribution. But what if it can collapse into incredibly dense, star-sized nuggets? These hypothetical objects, known as dark matter mini-halos, would have the mass of a mountain compressed into a space smaller than an atom, and their collective gravity in one spot could easily create this bizarre lensing signature. This anomaly is a ghost hunting tool. We are no longer just looking for dark matter's broad gravitational brushstrokes. We are searching for its finest, most concentrated fingerprints, revealed by the bent light of a galaxy we will never truly see. These phantom weights and gamma-ray flares hint at energies that can even reanimate the dead. Among the Whirlpool's vast stellar population, astronomers have identified what can only be called zombie stars. These are stellar corpses, white dwarfs and neutron stars that have long since exhausted their nuclear fuel and should be fading into cold, dark cinders. Yet something has caused them to flare back to life, shining with a brilliant and unexpected light that defies their final state. A white dwarf, for instance, is the Earth-sized core of a dead star, and it typically cools by emitting a soft, steady glow of residual heat. It should not suddenly erupt in a burst of energy that mimics the fusion processes of a living star. But some of these dwarfs do exactly that, flaring with intense ultraviolet or X-ray radiation as if they have been violently reanimated. One terrifying possibility is cosmic cannibalism. A white dwarf in a binary system might be slowly siphoning material from its companion star. When enough hydrogen from its victim accumulates on the dwarf's incredibly dense surface, the pressure and temperature can spike, triggering a runaway thermonuclear explosion. This is not the full supernova that destroys the dwarf, but a partial eruption, a stellar fever that burns fiercely for a time before subsiding, only to potentially flare up again when more fuel is stolen. It is a cyclical resurrection, a star that refuses to stay dead. For neutron stars, the resurrecting force is even more brutal. These ultra-dense remnants can also accrete material, but their immense gravity can crush the infalling gas so violently that it glows with incandescent X-rays, creating a beacon that pulses with the star's rapid rotation. In some cases, a neutron star's powerful magnetic field, the strongest force in the universe, can suddenly reconfigure itself in a starquake, releasing a titanic flash of energy that lights up the corpse for a brief, brilliant moment. These zombie stars challenge the very definition of stellar death. They reveal that the end of a star's life is not a quiet finale, but a potential prelude to new, violent phases of activity, powered by theft, collision, or the unimaginable stresses of matter itself. The forces that reanimate stellar corpses are dwarfed by the invisible architecture shaping the galaxy itself. Woven through the Whirlpool's spiral arms is a vast and complex magnetic field, a cosmic web of force that guides cosmic rays and sculpts the paths of gas clouds. Yet this field is not a uniform tapestry. Astronomers have discovered bizarre regions where the magnetic polarity suddenly flips, like a compass needle pointing south for miles and then instantly snapping to north. These are not gentle transitions, but sharp, violent boundaries where the magnetic field reverses itself over surprisingly small distances. Imagine the entire magnetic field of the Earth suddenly inverting between two neighboring cities. On a galactic scale, that is exactly what we are seeing, and it makes no sense according to our standard models. A spiral galaxy's magnetic field is thought to be generated by a slow, steady process called a dynamo, where the rotation of the galaxy twists and amplifies magnetic lines of force over billions of years. This should create a field that is large-scale and orderly, with smooth, gradual transitions. The existence of these sharp, localized reversals is like finding a perfectly square whirlpool in a smoothly flowing river. It points to a source of turbulence we do not fully understand. What could possibly cause such abrupt magnetic chaos? One possibility is that the violent history of galactic collisions and mergers has left a tangled imprint on the magnetic field. The gravitational turmoil of such events could have crumpled and twisted the galactic magnetic web, creating knots of opposing polarity that have yet to smooth themselves out. Another, more dynamic theory suggests that these zones are powered by concentrated bursts of star formation. When a cluster of massive stars is born, they live fast and die young, exploding as supernova in quick succession. The combined force of these explosions can blast through the interstellar medium, creating powerful shockwaves that violently compress and tangle the local magnetic field, potentially forcing it to reconfigure and flip in the process. These magnetic reversal zones are far from peaceful. They act as natural particle accelerators, where charged particles like electrons and protons can be trapped and boosted to near-light speeds by the conflicting magnetic forces, generating intense synchrotron radiation. This makes them hotspots of high-energy activity, invisible cosmic laboratories where the fundamental laws of electromagnetism are written large across the light years. Why does the Whirlpool host these magnetic scars when other similar galaxies appear more orderly? The answer may lie in its unique and turbulent life story, a narrative of collisions and bursts of stellar life that have left their mark not just in starlight, but in the very forces that weave the galaxy together. Even the galaxy's magnetic chaos is punctuated by something far more abrupt and powerful. From a single, unremarkable point within the Whirlpool, a signal erupts. It is a fast radio burst, a flash of radio waves that compresses more energy than our sun emits in 80 years into a few thousandths of a second. But this one is different. Where most FRBs are cosmic one-hit wonders screaming into the void only once, this one does something extraordinary. It repeats. It crackles to life again and again, a frantic, unpredictable heartbeat from the depths of the galaxy. Its very nature as a repeater makes it a Rosetta Stone for one of astronomy's greatest modern puzzles. Because it is so close, relatively speaking, we can study it with a clarity impossible for more distant bursts. The leading suspect for its origin is a magnetar, the ultramagnetic corpse of a dead star. A magnetar's magnetic field is so unimaginably strong that it could strip the information from every credit card on Earth from halfway across the galaxy. When these magnetic monsters undergo starquakes, sudden shifts in their rigid crust, they can release titanic waves of energy that we detect as a fast radio burst. The repeating nature of the Whirlpool source suggests a magnetar that is persistently active, its crust constantly cracking under the strain of its own internal magnetism. But there is another, more violent possibility. What if the repeater is not a solitary object but a binary system? Imagine a magnetar orbiting a massive, bloated star. As the star sheds its outer layers in a stellar wind, the magnetar could plow through this dense material. Each time it passes through a particularly thick clump of gas, the interaction could trigger a shockwave, launching a new burst of radio waves into space. This would create a cyclical, repeating pattern tied to the orbital dance of the two stars. The value of this nearby repeater is incalculable. Each flash is a data point, a chance to decode the precise physics of the emission. By analyzing the subtle twisting of the radio waves as they travel through magnetized space, we can map the invisible magnetic fields that thread the entire galaxy. This single, stuttering signal is not just a mystery in itself. It is a key, a tool for illuminating the dark, magnetic tapestry of the entire whirlpool. These dark nebula complexes are more than just shadows in the whirlpool's spiral arms. They are colossal structures of cosmic soot, so dense and extensive they blot out the light of millions of stars behind them, carving black voids into the galaxy's bright tapestry. While most dark clouds are stellar nurseries, pregnant with the gas and dust that will one day collapse into new suns, many of these whirlpool complexes present a profound puzzle. They are massive enough to birth entire star clusters, yet they remain eerily dark and silent. Their interiors are cold, quiet voids, showing none of the turbulent, glowing activity that signals the birth of a star. It is as if these stellar nurseries were built, furnished, and then abandoned before any stars could move in. So what could possibly halt the star-making process in such promising locations? One possibility is a failure of the initial trigger. For a cloud to begin collapsing into stars, it usually needs a nudge, a shockwave from a nearby supernova explosion or the gravitational squeeze of a passing spiral arm. Perhaps these particular complexes have existed in a strangely peaceful pocket of the galaxy, isolated from the violent events that normally kick-start creation. Without that external push, the cloud's own internal gravity might not be strong enough to overcome the gas pressure that supports it, leaving it in a perpetual state of suspended animation. Another, more intriguing idea is that star formation did begin but was abruptly aborted. Deep within these dark clouds, there could be what astronomers call failed protostars. These are condensed knots of gas that began the journey to becoming full-fledged stars, accumulating mass and heating up, but for some reason, the nuclear furnace in their cores never ignited. They are cosmic stillbirths, objects that gathered the raw materials for a star but lacked the final spark to truly come alive. They would linger there, cold and dark, hidden within the very clouds that gave them form. These silent complexes are a stark reminder that the universe is not only a place of brilliant creation, but also of quiet, unanswered potential. They hold a secret history of what might have been, a gallery of cosmic masterpieces that were never finished. What other unfinished stories are waiting, frozen in the dark within these sprawling clouds of dust? Some of these dark, silent nurseries may have violently expelled their own children. Streaking through the whirlpool's vast expanse are stars moving at impossible velocities, cosmic projectiles that have broken free from their gravitational chains. These are hypervelocity runaway stars, and they travel so fast they are effectively unbound, destined to flee the galaxy entirely and journey into the cold, intergalactic void. A typical star moves in a graceful, bound orbit around the galactic center, held in a celestial dance by gravity. But these runaways are different. They are celestial cannonballs shot from their birthplace with speeds that can exceed 1,000,000 miles per hour. The sheer force required to achieve such velocity is staggering, pointing to some of the most violent events in the cosmos. So what cosmic slingshot could possibly launch a star on such a desperate trajectory? One terrifying mechanism involves the supermassive black hole at the galaxy's heart. Imagine a binary star system, two stars orbiting each other as they swing perilously close to the central gravitational monster. The black hole's immense gravity could violently tear the pair apart, capturing one star into a tight orbit while flinging the other away at an unbelievable speed, like a stone from a sling. This gravitational assist is so powerful it can give the ejected star more than enough velocity to escape the galaxy's pull forever. But the central black hole is not the only possible launcher. Within dense star clusters, a close gravitational encounter between two binary systems can act like a chaotic cosmic pool game. The complex interplay of gravity can disrupt the delicate orbital dance, ejecting one or more stars from the cluster at tremendous speeds while the remaining stars recoil in a different direction. These runaways are more than just fast-moving points of light. They are forensic evidence, their paths tracing back to a moment of immense violence, whether at the galaxy's very core or in a crowded stellar nursery. Each one is a refugee from a gravitational catastrophe, carrying the story of its explosive birth across the light years. What other secrets of cosmic chaos are written in the trajectories of these lonely, speeding suns? Scattered throughout the whirlpool are the ghostly echoes of stellar catastrophes, expanding shells of gas that mark where massive stars once died in violent supernova explosions. These are supernova remnants, the beautiful and destructive aftermath of a star's final breath. Yet some of these remnants are deeply strange. They are orphans. At the very center of these expanding bubbles of glowing gas, where the dense, collapsed core of the star should be, there is nothing. No neutron star pulses with radio waves. No black hole betrays its presence with a telltale X-ray glow. The progenitor star, the one that caused all this destruction, has seemingly vanished without a trace. It is as if a bomb went off in an empty room with no sign of the person who lit the fuse. This presents a fundamental puzzle. Our understanding of stellar death is clear. When a massive star explodes, its outer layers are blasted into space, but its core must collapse under its own immense gravity. It should leave behind a hyper-dense remnant, either a rapidly spinning neutron star only a few miles across or, for the most massive stars, a black hole. So how does a star simply disappear? One possibility is that we are looking at the signature of a failed supernova. In this scenario, a truly colossal star might collapse so completely and directly into a black hole that the explosion never successfully propagates outward. The star would essentially implode, swallowing its own light, and the black hole would form so swiftly and quietly that there is no brilliant supernova flash to announce its birth. The surrounding gas shell, then, might not be from a traditional explosion, but from material the star shed in its final, unstable days before its silent collapse. The remnant we see is the last memory of the star, while the star itself has been erased from the visible universe. Another, even more exotic idea is that the remnant is there, but it is hiding. The neutron star left behind could have been born with an unimaginably powerful kick from the asymmetrical explosion. This cosmic recoil could have shot it away from the center of the remnant at hundreds of miles per second, fleeing the scene of its own birth so quickly that it is now far beyond the expanding gas shell, lost in the dark and impossible to link back to its origin. Or the neutron star might have rapidly spun down and developed such an incredibly thick crust that its magnetic field has been buried, rendering it dark and silent across all wavelengths we can detect. These orphan remnants are cosmic crime scenes where the prime suspect has utterly vanished, forcing us to reconsider the final moments of a star's life and asking a profound question. Can a star truly die without leaving a body? Orbiting the whirlpool at a right angle to its bright disk is a ghostly ring of cosmic debris. This is the polar ring, a structure that should not exist around a classic spiral galaxy. It is a halo of ancient stars and gas tracing a path over the galactic poles, a perfect perpendicular circle to the main disk's flat plane. Normally, such a feature is a telltale scar of galactic cannibalism. A larger galaxy will tear a smaller, passing companion apart, and the shredded remains of the victim get stretched out into a vast ring that settles into this unique polar orbit. It is the ultimate cosmic trophy, a display of a past conquest, but the whirlpool's ring presents a mystery that runs deeper than its strange geometry. When astronomers analyzed the chemical composition of this debris, they expected to find a signature matching the small companion galaxy we see with it today. The elements present in stars and gas act as a forensic fingerprint revealing their origin, yet the chemical makeup of the polar ring does not match that of its current neighbor. The ratios of heavy elements, the metals forged in the hearts of stars, are completely different. This simple fact shatters the straightforward story. The material in this ring did not come from the galaxy the whirlpool is currently interacting with. It points to a much older, far more mysterious act of violence. The whirlpool must have consumed a different, unknown galaxy billions of years ago, a victim whose own unique history of star formation gave it a distinct chemical identity. This long-vanished galaxy was entirely consumed, its stars scattered and its gas stretched into this eerie, perpendicular halo. The ring we see today is therefore a fossil of a forgotten murder, the only remaining evidence of a victim that has otherwise been completely erased from the cosmos. It forces us to ask what other ancient tales of collision and consumption are hidden within the whirlpool's beautiful spiral arms, written in a chemical language we are only just beginning to understand. This brilliant beacon at the whirlpool's heart flickers like a faulty cosmic light bulb. Most quasars, the intensely bright cores of active galaxies, change their brightness over years or even centuries, a slow and stately dimming and brightening as their central black holes consume matter. But the whirlpool's quasar is different. It flickers wildly, its output invisible light, X-rays and radio waves rising and falling in unpredictable fits and starts over mere days. This is not the steady glow of a well-fed engine, but the frantic sputtering of a cosmic motor on the verge of stalling. What could possibly cause such rapid and chaotic changes in an object of such immense scale? The accretion disk itself, the swirling river of superheated gas spiraling into the black hole, might be inherently unstable. Instead of a smooth, continuous flow, the disk could be plagued by violent magnetic storms or sudden temperature shifts that cause entire sections of it to flare up or dim almost instantly. Think of it like water boiling in a pot, with huge bubbles of energetic gas erupting to the surface and then collapsing, each one a brief, brilliant flash on an unimaginable scale. Another, more dramatic possibility involves a celestial shadow play. Imagine a thick, clumpy cloud of debris, perhaps the shattered remains of a star that wandered too close, now trapped in a tight, fast orbit around the black hole. As this cloud whips around, it periodically passes between the brilliant accretion disk and our line of sight, casting a deep shadow that makes the entire quasar appear to blink out for a short time. The sheer speed of its orbit would account for the incredibly rapid flickering we observe. This bizarre behavior is more than just a curiosity, it is a unique laboratory. By studying the timing of these flashes, we can essentially map the very edge of the black hole's gravitational grip, probing regions where space and time are twisted into knots. Why is this one quasar so uniquely unstable when others shine with such steady power? The answer may reveal that the chaotic final moments before matter vanishes forever are far more turbulent and complex than we ever believed. Floating between the stars are clouds of a treasure beyond any king's ransom. Spectroscopic analysis of the Whirlpool has uncovered vast, diffuse regions where the interstellar medium is laced with vaporized heavy metals. We are not talking about common elements like iron or silicon, but the most precious of all, gold and platinum, floating as a fine, hot mist in the void. The sheer concentration of these elements is the real shock. The conventional wisdom is that these metals are forged primarily in the catastrophic supernova explosions that end the lives of massive stars. While this is true, the amounts we see scattered through these whirlpool clouds are far too high to be explained by supernova alone. It is as if we walked into a forest and found the ground littered with perfect, machined ball bearings, far more than any natural process could possibly create. So what cosmic event is rich enough to seed the galaxy with such extravagant wealth? The answer points to one of the most violent and rare events in the universe, the merger of two neutron stars. When these ultra-dense stellar corpses spiral into each other and collide, they become alchemical forges of unbelievable power. In the heart of that collision, for a few fleeting seconds, conditions become so extreme that neutrons are captured at a frantic rate, building up atomic nuclei into the heaviest elements in the periodic table. This material is then blasted into space in a spectacular, glowing outflow known as a kilonova. The presence of these metallic vapor clouds in such high abundance is a smoking gun, forensic evidence that the Whirlpool Galaxy has recently, in cosmic terms, been the site of these incredible events. They are the lingering, dispersed aftermath of a titanic collision that created more gold than exists in our entire solar system, scattering stardust of unimaginable value into the darkness. What other cosmic treasures are hiding, dissolved into the light years between the stars? These vaporized treasures are the raw materials for new worlds, and in the nurseries of young stars, that material is assembling in strange new ways. Around infant suns in the Whirlpool, astronomers have found protoplanetary disks where the very dust itself has undergone a radical transformation. These swirling clouds of planet-building material are not just featureless grit. They contain vast regions where the dust has a crystalline structure, its atoms locked into an orderly, repeating pattern like a microscopic lattice of gems. This is the dust of future planets, and it has been fundamentally altered before the construction process has even truly begun. Normally, the dust in these disks is amorphous, its structure random and chaotic, like the atoms in a pane of glass. For it to become crystalline, it must be subjected to a sudden, intense blast of heat, a shock that rearranges the atoms into something more like the ordered structure of a diamond. These are not gentle processes. A quiet, steady warming would not do the trick. This requires a violent, flash heating event, powerful enough to melt the dust grains in an instant and allow them to recrystallize as they cool. So what delivers this cosmic heat treatment? One prime suspect is the young star itself during its most volatile tantrums. In its infancy, a star can unleash colossal flares, sudden eruptions of energy that dwarf anything our own sun produces. A single, nearby megaflare could bake the inner regions of the disk, turning dusty chaos into crystalline order. Alternatively, the shockwave from a nearby supernova explosion could have rippled through the disk, superheating the material as it passed. This discovery changes our entire picture of planet formation. If the building blocks of planets are crystalline, their physical properties are completely different. They are stronger, they stick together in new ways, and they interact with light differently. absorbing and radiating heat in a manner that can alter the entire temperature profile of the developing solar system. This could lead to the formation of planets in orbits and with compositions we would never predict from our own solar system's example. We might see diamond-rich worlds or entire planetary systems that assembled faster and in more bizarre configurations because their raw materials were pre-processed by a sudden, forgotten cosmic fire. The very nature of a planet may be determined by a single, violent day in the life of its stellar nursery. Even the ticking of the cosmic clock is not constant throughout the Whirlpool Galaxy. By observing the rhythmic pulses of variable stars, those reliable celestial metronomes, astronomers have detected a faint but persistent anomaly. The light curves from these stars, their predictable brightening and dimming, show minuscule timing discrepancies that cannot be explained by distance or motion alone. It is as if time itself is flowing at slightly different speeds in different parts of the galaxy. This is a direct echo of Einstein's theory of relativity, which tells us that gravity warps not just space but time itself. A clock ticks slower in a stronger gravitational field. The subtle shifts we see in these stellar heartbeats point to the presence of hidden mass concentrations scattered across the whirlpool, their immense gravity creating localized pockets of slightly slowed time. We are not just mapping mass, we are mapping the very fabric of space-time as it is stretched and compressed by the invisible universe. But the mystery deepens when we ask what is creating these gravitational pits. They do not always align with the visible matter we can see. Could these be the signatures of those hypothetical dark matter mini-halos, knots of invisible matter so dense they warp time in their immediate vicinity? Or is there something even more exotic at work? Some physicists wonder if we are seeing the faint imprint of cosmic strings, theoretical defects in the structure of space-time left over from the Big Bang, flaws in the universe's fabric that would possess immense density and warp time around them. The time dilation anomaly is perhaps the most profound mystery of all, because it does not just challenge what we see, it challenges our most fundamental experience of reality. It suggests that the Whirlpool Galaxy is not a static collection of stars, but a dynamic landscape of flowing time, where the past, present, and future are relative concepts shaped by the hidden weight of the cosmos. From phantom arms to crystalline dust, each of these 25 phenomena reveals a universe that is stranger and more dynamic than we ever supposed. The Whirlpool Galaxy is not merely a subject for our telescopes, but a living, breathing laboratory. Its chaotic core, its whispering dark matter halo, and its glittering stellar factories all operate on the frontier of our understanding, constantly challenging the rules we thought were set in stone. Every mystery solved seems to unlock two more, a beautiful and humbling cycle of discovery. This single galaxy, a pinprick in the vast cosmic ocean, reminds us that the universe is not a solved puzzle. It is an endless well of wonder, always holding new surprises just beyond the edge of our current vision, waiting for the next curious mind to look up and ask a new question.